Let's talk a little more about parabolas, the graphs of quadratic functions. So does this parabola open up or down? Well, it's down. So we would say down. The vertex is going to be that point right there. Looks like it's at -3 to the left and then up 4. Not the other way around, not 4, -3 or anything else. You always do the x coordinate first. So that's going to be the vertex. Okay. All right. What else? Well, we need the axis of symmetry. The axis of symmetry is the line that splits this thing perfectly in half. So it's going to be that guy right there. Now, I think it stands to reason that, yeah, it definitely has to go through the vertex, doesn't it? And because it's a perfectly vertical line, it's always going to, well, every point on the line has the same x coordinate. And in this case, they all have the x coordinate -3. So it's always going to be x equals, and then the x coordinate of the vertex. And it does say, give me the equation of the axis of symmetry. Here's a mistake a lot of people make. They just say -3. And I say, -3 is not an equation. It's just a number. I need the entire equation. So, you just do that. All right, the last thing is the intercepts. Let's about this color. Okay, so I see that I've got an x-intercept at -5 and another one at -1. So x-intercepts are -5 and -1. Okay, what about the y-intercept? Because it always has a y-intercept. Well, it hits the y-axis also at -5. Okay, so there is, yeah, so that guy right there, that's going to be my y-intercept there in red. And that is how it's done. Okay, so once again, we're going to graph 5 points, 2 to the left and 2 to the right of the vertex to so we can get a nice pretty graph and impress all of our friends. Okay, so first it'd be helpful to know what the vertex is. One way to get the vertex is to use the formula. The x coordinate of the vertex is always -b over 2a. Well, b is -24 and a is -3. Okay, so that's going to simplify to -4. So that's the x coordinate of the vertex. So once again, we can say, all right, let's back it up a couple, and we'll go forward a couple from that vertex, and we'll have symmetry to speed things up, and then we just plug each of these x values into the function to figure out what the corresponding y values are. Once again, I'm just going to go with the calculator because I want to go there anyway to do something else. So there's the function in there, and I can go to right there. And I can say, hey, look, there's all my y values when I plug those corresponding x's in. So -5, 4, 7, 4, -5. Okay, just using those 5 right there. So, so that's what's going on with those guys. And of course, I mean, you could always just, look at the graph and say, all right, this is what it's supposed to look like. So when you plot your 5 points in Alex, it should look like this. Okay. Now, so and then we've got the vertex here right in the middle at -4, 7. Boom, 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 right there. Now, one thing you could do is to double check that you've done that little formula, negative b over 2a to get the x coordinate of the vertex. One thing you could do is go to the calculator and go second trace and use either minimum or maximum. Well, our vertex is at the top of the parabola. It is a maximum point. So I'll pick option 4. And notice it says maximum. And then using the left and right arrows, I'm going to answer the questions. It says, what is your left bound? So I go to the left of the vertex, the point I'm looking for, and hit enter. And it says, what's your right bound? And I hit enter. And then best guess, enter. And it gives me a vertex. It often doesn't give you exactly the right answer, but darn close. So it's -4, 7 is what the calculator meant, which is exactly what we got. And so that's another way to get the vertex, or at least to double check that you did it correctly. So that's a very handy thing. Now this is going to look at least a little bit familiar, but find the vertex and the x-intercepts of the parabola. Okay, they want you to do x-intercepts first, but it doesn't really matter. Okay, so the vertex, they use one method. I don't really bother using it. Their method's fine as long as they're x-intercepts, but you're not always going to have x-intercepts. So I'm just going to do the -b over 2a trick to find the x coordinate of the vertex. So negative, let's see, b is 8, a is 1, and we get -4 again. Wow, that was dumb luck. Okay, so the vertex is going to be -4, comma, something. Comma what? Well, let's just do y of -4. Plug in -4 for x. Let's see, what do we get? We get 0. Okay, so there's the vertex. -4, 0. All right. Now, for x-intercepts, remember, x-intercepts are on the x-axis for any function where y is 0. You're not up here where y is positive. You're not down here where y is negative. You're where y is 0. So if you want to find x-intercepts, you replace y with 0. And now you can solve with completing the square, quadratic formula, graphing the left, graphing the right, factoring, whatever, if it factors. It does factor, in fact. X minus 4 times x minus 4. If I take the square root of both sides, I get that. And then if I add 4, I get that. Whoops, I get that. And that is, I think, going to do it. Except, yeah, I thought I made a mistake. Yeah, I don't know why I put a minus there. Yeah, that should be plus, and then therefore that should be minus. There. So, yeah, that makes more sense. So it turns out that, yeah, when x is -4, well, that's exactly when x is -4 there. So this time the x-intercept coincides with the vertex. Usually you get two x-intercepts when there actually are any. But on this case, because it coincided with the vertex, it turned out there was only one, and that's just fine. But that's the process. Okay, so here's how to get the x coordinate of the vertex, and then once you have that, you plug that number in, for x to get the corresponding y coordinate, and then boom, you got your vertex. To get the x-intercepts are on the x-axis where y is 0. So replace y with 0 and then solve. And then, of course, there are other techniques you can do. For example, doing the max or min trick instead of that and that. Do that on your calculator, and that'll work every time. So pretty slick. All right, so now let's do the same thing again, except this time we're going to find the x-intercept and the y and the vertex using the calculator. Okay, I could have used the last function, but whatever. So step one, obviously, put the function into your calculator. Okay, and we've got that. Now, once we've got that, let's go to the graph. There it is. And I can tell that the vertex is pretty close to 2, 0. Looks like maybe more like 1 3/4 0. But what it is exactly, I don't know. And the fact that there were all these decimals in the for the coefficients suggests that it's not going to be nice, neat numbers. Okay, so I do know from the graph that the vertex is at the top of the parabola, the maximum point. So I'll go second trace maximum. And then I need to say, all right, go to the left of that vertex. Okay, the cursor is to the left. I hit enter. Now the cursor is to the right. I hit enter. For best guess, you can say enter. All right. And let's see if we can understand what we're reading here. So the vertex is going to be, it's going to have an x coordinate of 1 point. You know what? I don't even remember what they said to do. I'll just go nearest 10th. How about that? 1.8, and the y coordinate. I'm thinking it probably 0. Okay, and why would I say that? Well, here's why. Because this y coordinate right here for the vertex, it's negative 3.1 times 10 to the negative 12th power. So what does that look like? It looks like this: negative 0.0000000000031. So it looks like the calculator was trying to do 0 in scientific notation and was off just a teeny bit. So I'm just going to say 0. After all, to 11 decimal places, 0 is the correct answer. Okay. All right. So we got that. What about x-intercept? Well, again, x-intercepts occur where y is 0. But we can, one way to do it would be to go to second trace again. And this time, pick option 2. The 0 of a function is where the name of the function, y, is 0. In other words, x-intercepts. And we do the left bound, right bound thing again. So I'll go to the left and hit enter, go to the right and hit enter. And this time I'm just looking for the x-intercept, not the high point necessarily. I mean, they might be the same thing. In fact, they will be because of that 0 from before. All right, and we get that same thing. Okay. So that is how you can get x-intercepts with the calculator. Let's see. So x-intercepts. Whoops, I want a dash there. I know it's not important, but it's important to take pride in your work. Okay. So the x-intercept is going to be 1.8. Okay. And that's kind of how it goes. I know this video is really getting long, but oh well. It's your blessing, right? Okay, so write the quadratic function in this form here. Okay, so we got to figure out the a. Well, we already know a is 3, b is 30, c is 72. So a is 3. Cool, we got a. And then remember, hk, that is the vertex. Okay, so the easy way to do it would be to just say, let's use the min-max function on the calculator to find the vertex, or do the x equals negative b over 2a trick and say negative b over 2a is negative 5. So the x coordinate of the vertex is negative 5. So f of negative 5, to get the corresponding y coordinate of that vertex, could be done this way. and we get -3. Okay, so it turns out that's our h, that's our k. So the function can be rewritten as f of x equals a, which was 3, times x minus h, which was -5, and then squared, and then plus k. We can tidy that up as 3 times x plus 5 squared minus 3. Now, what you should do at this point is plug that in for y1, that in for y2, go to the table, see if they match, because they're supposed to be the same function, just written in different forms. You really need to do that before you hit submit on Alex or something like that. And like I said before, instead of doing this stuff to get the vertex, which wasn't too bad, you could just plug the function in to the calculator and use the min or the max function as appropriate. On this one, it'll be the minimum function because a is positive, so it's opening up. All right, one more. Medical equipment industry manufactures X-ray machines. The unit cost C depends. So the cost for to make just a single X-ray machine depends on the number of machines made. That makes sense. If X machines are made, then the unit cost is this function here. So X is how many machines, and C is the cost for an individual machine. So how many machines must be made to make that unit cost as small as possible, to minimize it? Well, let's just be honest. You're probably just going to go to the calculator. So let's plug in the function to start things off into the y equals menu. So there's the function. Now, it's a word problem and it has big numbers. So my regular old standard Zoom 6 graph probably won't show much. So let's go to window, and X stands for number of machines being made. Well, they're not making -10 of them. They certainly won't go below 0. And I don't know, they probably won't go over, I don't know, maybe 100 machines made. And then Y, that's our C of X. That's the unit cost. I don't know what that should be. So I'll let the calculator pick that for me by going Zoom 0. And there I see the function. Let's see what it shows. Ooh, 12,658. That's the bottom of the graph. And 29,458 is the top of the graph. Now, from the picture, I can see that the vertex is going to be somewhere off to the right. So apparently 100 machines was not enough. So I'll push this out to like maybe 500 machines. That's probably enough. And then I'll let the calculator pick the y min and y max again, the minimum cost per machine and the maximum cost per machine by going Zoom 0. And oh, there's that minimum point. Okay, that's what we want. So second trace minimum, option 3, and go to the left of it. We're just find the vertex. So the -b/2a thing would work too. Go to the right of it, best guess, and it looks like 190 for X and 77.98 for Y. So what that means is, in order to minimize the cost for each machine, they need to make 190 machines. And the minimum cost per machine at that point is going to be $77.98 per machine. These things are kind of spendy. But then again, they're really, really helpful. So that is the lowdown.